Good morning, guys. Welcome back to my channel. Uh, Today's topic is going to be on the ARIMA model. Though there are many models like this, we have this ARIMA and the ARIMA model, but I'll talk mostly on the ARIMA. What is ARIMA model? ARIMA model is a auto-regressive integrated movie average model. It's a univariate single model, and then this model is a forecasting technique that projects value of a series based on its own characteristic. It's mostly a short-term forecasting model. I think a function or a series has at least 40 historical data points. It's mostly where we use ARIMA model for. Talking about ARIMA model, this model was first put into written by I think two authors. They are called Box Jinksons, and those authors named it ARIMA because of its nature. So this ARIMA mostly tries to show or exhibit a stable behavior of a time series data. You understand? And it tries to show the minimum amount of outliers. Things that what outliers simply means are these are not things that are there which are not supposed to be there. So, and we have some very few important concepts that I need to talk about. ARIMA model one, it's mostly check on stationality. This stationality simply means the how stable a series is over time. Stationarity, stable. That's why it's called stationarity. It's just to check how stable a series is over time, and it's mostly functions that has trend prices mostly prices in terms of maybe products have volatility. Although it gives room for few ups and down, but the few ups and down are predictable. Let me go to one important point when trying to use ARIMA model. Due to the behavior of a data series, the data series cannot be 100% stable. So there will be a time we notice you will see a data that is stable, and then a process whereby data won't be stable. So the process of trying to transform a data series that is not stable into a stable data, that is non-stationarity into a stationarity series, is called differencing. And they will also call differencing one, and that is first difference and second difference, depending on your aim and objective of using the ARIMA model. I think the second concept is autocorrelations. This autocorrelation is just trying to see how a data is related to itself over time. It's just like how maybe which example will I come up with? The prices of goods, how it's been kind of stable over time, and how it's being related to itself, like predictable or not predictable. Um, the process of trying to um, trying to see how the data are related to each other is called lag. The referring to a particular year, that is a current year, back to the previous year, is what we call a lag 1. And we also have lag 2. That means year 1, year 2. You are referring a current price or a current data to a previous data, or maybe a previous price. We have +1 and -1. Any value close to +1, you call it we say it has a high positive correlation. While a value close to -1, we say it has a high negative correlation. This mostly, if you're trying to put them into a graphical form, but it's mostly put into a graphical form for graphical representation and then more understanding. So the act of putting it into a graphical form is called a choreogram, and then whereby you are trying to put two 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 lags, maybe lag 1 and lag 2, into a particular graph. It's called choreogram function, since it has lag 1 and lag 2. So let me go to the next one, which is autoregressive models. These autoregressive models are inside ARIMA. We have the AR and the MA. The AR parameters are autoregressive, and the MA parameters are the moving average. These two are always together. AR and MA, them coming together towards form the ARIMA, the autoregressive, and then the movie average. Then the I stands for integrated. That means ARIMA, average, autoregressive integrated moving average. Its function mostly is talking about one with, that means, a single parameter. Is x function t equal to a function 1 times x function t minus 1 plus e function t. Wow. Where x function t equal to time series under investigation. That is, this time series under investigation can be the years of data you're trying to investigate. Probably, as I earlier said, 40 data historical points. While the a function 1 is equal to autoregressive parameter of order 1. And this order 1, I think I explained it, is just first differencing. Why x function t minus 1, this is time series lag 1, t minus 1 time series lag 1, and then e function t is equal to error time. This error time, I think it stands for outliers. It gives room for unexplainable behaviors or of data, some variables that cannot be explained, and they are captured during the computation of the data of the function. Now, if the parameter has two parameters, that is, it's going to be a function 2 instead of a function 1. It's going to be a function 2. since it has a function too, definitely it's going to have um, um, probably, I'm not really sure, but it is going to be x function t minus 2, that is the order of 2, like 2 plus error term. Thank you very much, and God bless you. And if you have any question, please try and ask. These topics this topic is very important for student of economics and statistics, and it's mostly used on the prices on goods that has volatility. For example, prices of crude oil. I know everybody knows how crude oil affects the international market, uh, and it has high volatility, and any change in price of such goods that affects the microeconomy of any society. Also the prices of gold. So it's mostly used to estimate those uh, functions, and also the prices of of stocks, probably in the money market and capital markets. Those are where ARIMA models are usually used in. Thank you very much, and God bless you.